Hello everyone. In this presentation we'll be covering some basic mechanics, including mass, gravity, force and energy, and how to calculate mechanical power from these. First up, what is mass, and how does this differ from weight? Mass is the term used to describe the amount of matter in an object, whereas weight describes your mass once the effect of gravity has been applied. These two measurements are relatively interchangeable in daily life, as it's very rare to find yourself not under the effect of gravity. For instance, if you were to go on a diet, your mass would decrease as you eat less food. And whether you are on Earth under the effect of gravity or floating around in space, your mass would stay the same. However, in space, there is no gravity to pull you down, so you become weightless. Even though your mass is still the same, your weight will have changed. So if you stand on a set of scales, it will measure the downward force you exerted in newtons and convert this to your mass in kilograms on the screen. The unit for mass is the kilogram, hence why standing on the scales will show kilograms, or stone if you have it set to imperial. A 50 kilogram mass will have a 50 kilogram mass wherever it goes, but its weight will depend on gravity, and the weight is measured in newtons, named after Sir Isaac Newton. Gravity is measured as an accelerating force, which is why objects speed up the further they fall, rather than remaining constant. The measurement used is 9.81 meters per second squared, and this figure is crucial to almost all mechanical calculations. Back to weight now, and that 50 kilogram mass. As we said before, the unit for weight is the newton. To work out the weight of an object in newtons, you multiply its mass by gravity, which is 9.81. So this would be 50 kilograms times 9.81, giving you a measurement of 490.5 newtons. If you recall, gravity is an accelerating force, so your 490.5 newtons will be a unit of force. Crucial to remember for your revision in your exams is if a question states the mass of an object in kilograms or tons, it will need to have gravity, or 9.81, applied to it to know its force in newtons. Equally, if a question states a load in newtons, then it has already had gravity applied and been multiplied by 9.81, so you wouldn't need to multiply it again. Once you have an object's weight, or force, in newtons, it can be applied to movement such as lifting. This is applicable to, say, a mechanical winch and calculating whether it will be able to lift the object off the ground. Once you apply movement, or distance, to the calculation, you are then calculating work done, which is measured in Newton meters, or joules. So what we have so far is that mass times gravity equals force, which is measured in newtons, and that force times distance is work done, which is measured in Newton meters, or joules. Written in full, this would be mass times gravity times distance equals work done. So our 50 kilogram mass multiplied by gravity, or 9.81, giving us 490.5 newtons of force, now has to be lifted 5 meters into the air. The unit for length is the meter, so it would remain at 5. If the measurement was 50 centimeters, for instance, it would be written in your calculations as 0.5, as it is half a meter. So our mass times gravity times distance is now 2,452.5 newton meters, or joules. To calculate mechanical power in watts, for this we now need to divide it by a set amount of time. In this example, we'll keep it simple and say it takes 10 seconds to be lifted those 5 meters. We now need to use our figure of 2,452.5 newton meters and divide it by the time taken, so 10 seconds, which will give us a final answer of 245.25 watts. As power is the rate of doing work, what we have done here is divide our work done by the amount of time taken. Some key points to remember from this is that mass times gravity equals force, which is measured in newtons, and that if a question has a load measured in newtons, it has already been multiplied by 9.81. If a load is measured in kilograms, it hasn't had gravity applied yet and must be multiplied by 9.81. Looking out for these at the start of a question would be crucial to using the correct figures for the rest of your working out. Additionally, if a question is asking for an answer in newton meters or joules, it only needs to have mass times gravity times distance applied, and time can be ignored. If it is asking for average power, you would do the full calculation of mass times gravity times distance divided by time. Also, the unit measurement of time is the second, so when dividing by time it has to be in seconds. So if it took a load 2 minutes to lift, it would be divided by 120 seconds and not just 2 to symbolise the minutes.